Yeah, you have a Raspberry Pi just laying around, and all you do with it is play retro games. Well, you know you can do more than that than just play retro games. Have you ever looked at your Pi and you see these little GPIO pins on there? And you're like, oh, I wonder what they do. Well, let me show you what you can do with them. You can turn stuff on and turn stuff off with them, and all sorts of things. Today, what I got here? I got some LED lights. Let's start with that. I want to show you how to use your Pi to turn on and off lights. And if you can do that, you can turn on and off other things. So let's go do this video. What I have here in my hand is a little LED light bulb. It's not necessarily a light bulb, it's a diode. The difference between a diode and a light bulb is a diode can only accept power one direction. Shh. Not this direction, that direction. A regular light bulb can accept power either way, so we have to hook it up correctly. You can identify the polarity of this LED by looking at the legs. One leg is longer than the other leg. That longer leg is the positive side. You can also look at the case if you have really good eyes and see one side is flat. Either way, let's hook it up to a battery and see if it turns on. I'm going to connect the red to the positive side, the longer leg, and I'll connect the black to the negative side. Another thing about a diode is it won't turn on unless it gets the right amount of power. For example, if I hook up the plus to the battery to the negative, it won't turn on because I need to have 3 volts. And each battery is 1.5 volts. Kind of cool, huh? Now let's see if we can put it on the Pi. First you have to look up the chart to see which pins do what. If you look at the chart, it says this top pin here is 3.3 volts. So I'll put the positive on there. And then the ground, well there's several grounds, it's like the 5th one down. 1, 2, 3, 4, 5. It turns on, but that's constant. However, it's recommended that you put a resistor on it so you don't burn out the bulb, especially if you hook it up wrong. So I'm going to unhook this, and I'm going to put a resistor into line. It doesn't glow as bright this time, but at least I know I'm not going to burn it out. Now that I know it works, I don't want to leave it on all the time. So what I'm going to do is I'm going to unplug it from the constant, and then according to the chart, the pin 17 is a pin that is programmable. And I'm going to plug it into pin 17, which is the 6th one down. 1, 2, 3, 4, 5, 6. After I do that, we have to do some software to program to turn it on. Well, let's go to the computer.
Boot up your Pi. Type in this, Python, enter. Now type import GPIO ZERO, enter. On the next line, type in LED equals GPIO ZERO dot capital LED left parentheses 17 right parentheses. Gotta have those parentheses. Enter. On this line, type LED dot on left parentheses right parentheses. Enter. Notice your LED light should have turned on. If not, try hooking it up backwards. You might have it hooked up backwards. I hate it when that happens. Now, let's try LED dot off left parentheses right parentheses. enter. Now that you know you can turn the light on and off from the terminal, let's quit out of here. QUIT, left parentheses, right parentheses, enter. Now what we're going to do is we're going to create a file. So type in sudo nano, and our file will call led underscore charles.py for Python. So the line we just typed, this line is a terminal command to open the nano text editor used to create or edit a file named ledcharles.py with superuser privileges. However, this line itself isn't part of the Python code. So our first line here, we type in from GPIO 0 import capital LED. This line imports the LED class from the GPIO 0 library. The next line I want you to type in is import time. This line imports the time module, which allows you to do various time-related functions. On to our third line, LED equals capital LED, left parentheses, 17, right parentheses. This line initializes the LED to be controlled through the GPIO pin 17. In line 4, we're going to say 4 space underscore space in range, left parentheses, 5, right parentheses, and at the end we have a colon. Don't forget that colon. So what's happening in this line is it's going to start what they call a for loop, which goes 5 times because there's a 5 in there. Now for the next line. In this line, you hit the tab key to indent it first. Then type in led.on left parentheses, right parentheses. So what does this line do? Well, duh. This line turns the LED on by calling on the method of the LED instance, don't you know? So you're probably asking, why did we indent that line? Well, in Python, an indentation is used to identify the blocks of code that are used for our loop. Remember, we started the loop in the line before. Well, we have to indent it. Now for our sixth line. Hit the tab button, type in time.sleep, left parentheses, 0.5, right parentheses. This line pauses the program for 0.5 seconds. Next line, hit tab again, type in led.off, left parentheses, right parentheses, and you guessed it, this turns the LED off. Let's make it sleep again. Type in tab time dot sleep, left parentheses, 0.5, right parentheses. And of course you know it, it's going to make it sleep for 0.5 seconds. I think our little program is good enough for now. Let's save it by hitting Control S. Oh, what's it asking me here? Save modified buffer? Well, of course, why? To exit back out of the terminal, you hit Control X. So you see, we're back at the terminal now. All we want to do is run our program. So our program's written in Python, so we'll type in Python. And then the name of your program. Of course, mine was LED Charles PY. Okay, I'm getting ready. I'm going to hit the enter button. Oh boy.
Ooh, now's the time I've been waiting for. I'm so excited. I can't stand it. It's going to turn on. It's going to turn on. 1, 2, 3, 4, 5. And that's how it goes there, boys and girls. Isn't that great? What? Are we out of time again? Boy, there's a lot of things I would like to show you in this video. Like use one of these little breadboards to put your circuits in and help you get organized and everything. But we'll have to do that in another video, I suppose. Till then, if you like this video, leave a comment, like, and subscribe. Till then, we'll see you later. Raspberry Pi. Pie. Goodbye!